guys and girls to another cloud interview question answer video. You guys and girls really liked my last video on solutions architect interview questions and wanted me to cover a few more questions. So here we go. Questions we'll cover in this video are: how to make a design highly available, how do you design automated unit testing in your CI/CD pipeline, how can you access your application using desired URL with load balancer and API gateway, how can a server send messages to the client using API, how would you insert data into Redis or Memcached, so basically what are your caching strategies, can you tell me a couple technical challenges you faced with your current project, give me an example where you have used AWS well-architected framework, and what is cloud computing / AWS Service X. For those of you who are new to this channel, my name is Raj. I'm a senior specialist architect at AWS for serverless and containers. Previously, I was a distinguished cloud architect at Verizon, and I'm also a published Udemy and Pluralsight author. I'm also a public speaker and author of multiple AWS official blogs. All right, with that, let's jump into our question number 1, how to make your system highly available. So in this case, an interviewer will probably give you some design or tell you that, hey, how about a typical microservice with elastic load balancer in the front, and the back end is running on Amazon EC2, and the database is Amazon Aurora. So to make highly available, one typical answer you folks will give is, I will spin up multiple of everything. In that logic, you might say, I'll spin up multiple load balancers and the load balancer not be a single point of failure. But that would be wrong. Amazon load balancers are highly available out of the box. So what that means is, under the hood, this service is implemented into multiple availability zones. So even if one availability zone goes down, this load balancer will still be up and running. So how about EC2? Is EC2 highly available? Nope. For EC2, you have to provision multiple EC2s in separate availability zones to make these highly available. How about Amazon Aurora? So by default, Amazon Aurora is not highly available. You can choose multi-AZ deployment for Aurora, but that comes with additional cost. So on that note, you might get the question, how about Lambda? So Lambda is highly available out of the box. You do not need to deploy multiple Lambdas for the same application code. And again, highly available out of the box means under the hood, this service is deployed into multiple availability zones. So another very popular technology right now, Kubernetes. So is Kubernetes highly available out of the box? No, it is not. You need to spin up multiple pods for the same container in different availability zones using pod topology spread constraints. So even if one pod goes down, this pod topology spread constraints ensures that the other pod will come up in different availability zone and not in the same AZ. All right, moving to the next question. How do you design automated unit testing in your CI/CD pipeline? So this is kind of a real world question. If you have just studied theoretically, you would probably not know this answer. But if you have done this in your project, then you would know this. So let's go through the answer. So a typical system architecture will look like this. So when it comes to manual unit testing, the tester will basically call this application with predefined input, and then the responses should match with expected output. So generally for unit testing, the tester will directly call the EC2 or the Lambda code or the code running in Kubernetes. So all this is very manual. So now if you want to move this manual user calling with predefined input to some sort of compute layer, one way would be to have another Lambda. So this Lambda with the green icon, instead of the user typing in all the input and calling the APIs or calling the code, all that will be in the Lambda itself. And to do this, you will utilize some sort of testing framework such as JUnit framework. And in this JUnit framework, you will tell, hey, call this application code with this input, and the output should match this exact output I'm giving you, or it should be one of the outputs that I'm giving you in the program. In this case, this testing Lambda is still being called by the manual tester. So to make it fully automated, this Lambda needs to be called from a CI/CD pipeline. So how do you do this? So at the end of the day, you just need to invoke the command to run this test lambda. And if you are using a JUnit framework, the command will look something like that if it is written in Python. So if we look at the example CI/CD flow for lambda, so we have developer checking in code repository, and this AWS code build is building the code. In this AWS code build, you have the option to invoke commands. So the command I showed you in the previous slide, you can invoke that from this AWS code build, and this code build will invoke your application lambda or application code and run those JUnit commands. So this is a separate topic on its own. If you want to know in a little bit more detail, check out my separate video where I do automated unit testing using AWS code build and JUnit. I'll give the link up top. So next question, how can you access your application using desired URL with load balancer and API gateway? So probably you know the answer with load balancer. So you have an application load balancer, let's say fronting this bunch of lambdas, and the application load balancer will give you some sort of cryptic DNS like 123xyz.com. But what we are trying to do is access this load balancer with a desired URL such as www.store.com. So what you will do is you will create a Amazon Route 53 DNS entry, a record specifically, where any traffic coming to www.store.com will be forwarded to this load balancer. So the advantage of this is even if the backend changes, for example, backend changes to pod and this elastic load balancer changes to some sort of ingress, it doesn't matter. You can start forwarding the traffic to this new elastic load balancer without the user changing anything, because the user can still call www.store.com. So now the trick part is, what about API? So for APIs, the API will be hosted in API gateway, and API gateway will give you some sort of a cryptic invoke URL, and that's what you need to use to invoke. So naturally, you will think this will be very similar. So you might have Amazon Route 53 record, a record pointing to API endpoint to invoke the URL. So that would be wrong. So this is the part I want you guys and girls to know. So you do with API gateway using custom domain flow, where the DNS A record will be pointing to the API gateway domain. So the Amazon API gateway service itself running on that account/region, it is not going to point to your API endpoint. So once the traffic for that specific URL gets forwarded to Amazon API gateway, in Amazon API gateway using API endpoint mapping for custom domain, you need to forward the traffic to your specific API. And then your user can invoke the API via the actual domain. So I have a separate detailed video along with demo on this one as well. I'll give the link up top. Check it out if interested. On the same note, a very common question that comes in cloud interviews is, how do you choose whether to use application load balancer or API gateway? Both cases, you can select either or to front your backend. So when you get this question, you ask interviewer about the system requirement, and you just have to study for this one. So I have multiple videos on this. So if you want to study just one, study this load balancer or API gateway one. That's a super common question. But if you have time, then check out the other ones as well, especially serverless versus EC2, Kubernetes versus Lambda, and different container options if you are going for container positions. Next question, how can the server send messages to the client using API? So this API is what makes this question tricky, because you might think, all right, so the server can send messages to the client using SNS. You can notify using email, text messages, etc. Or maybe server can put a message into SQS and the client can read from there. But that won't be API driven. They will all be asynchronous. So that won't be the correct answer. So with API, in general, you are familiar with request response, where the client invokes the API and the API goes to the server and then the server responds back. So in this model, only client can invoke the server, server cannot initiate connection to client. So to do that, you need to use WebSocket APIs. With WebSocket APIs, a client first initiate a connect request, and then this connection stays open. And using this connection, not only client can invoke server, but also server can invoke client. So this is a bidirectional API call. The connection stays open, and then server can send messages to the client. And you can achieve this using either load balancer or API gateway. So what are some of the use cases for WebSocket? Chat applications such as WhatsApp, chatbots, Telegram, where the server can also send messages to the client such as you. Next question, how does data gets loaded into Redis/memcached? So whenever we get the question like how would you improve performance on your system, we always say, yeah, I'm going to use a caching layer such as Redis or memcached. I will always check the cache first, and then if the data is found on cache, I'll return from cache. That will be super fast. Yes, but who or what process inserts the data into the cache, and in what way? So there are two methods of doing this. So with lazy loading, when the user or the application tries to read something, the application code first checks with the cache. So Amazon Elasticache, just for those of you who don't know, Elasticache is the Amazon caching service, but it runs either Redis or memcached. If that information is found on the cache, then we call it cache hit, and the information is returned to the user. If the information is not in the cache, then we call it cache miss, and in that case, the code goes to the underlying storage, in this case the database, receives the data, and the backend code at this time also writes this information to the cache. And of course, the same information is returned to the user as well. So this method of loading the cache is called lazy loading. So what are some of the features of this lazy loading? Only requested data is cached, right? So if a user never requests a data to be read, that data is never loaded into Elasticache. So it avoids loading unnecessary data. However, there is increased response time with cache miss. Since the data is loaded during the cache miss, so it increases the response time when the cache needs to be loaded. And there is a possibility of stale data. Let's say you read some data and it was cache miss, so it loads the data from the underlying database to the cache. Now, let's say the data got updated into the underlying database. However, your cache still have the old stale data, because with lazy loading, data only gets loaded during the read, and for the next read after the data is updated, it will still find the data in the cache using the primary key, but it will return the outdated data. There is no way to go and update the stale data with lazy loading. Now let's move on to another approach, which is write-through. With write-through, when the user is writing, as in inserting some data, updating data, or deleting data to the database, during this write, the code also inserts the copy to the cache. So it doesn't wait till the reading. Anytime a new data is written, updated, deleted, it also does the same to the cache. So what are some advantages? So data in cache is never stale, because anytime a record is updated, it's also updated in the cache at the same time. With write-through, you incur write penalty, because the write will take a little bit longer because the code has to write to the cache as well. And one method of taking care of stale data with lazy loading is to implement time to live, where after a certain amount of time, the data will be removed from the cache, and during the next read, updated data from the database will be loaded to the cache. So which caching strategy should you choose? There is no definitive answer. You should choose based on the nature of the application. Whether your application does more reading or more writing, what is the nature of the application, are there frequent updates of the data, etc. So the next question is, can you tell me a couple technical challenges you faced with your current project? So this question is meant to see if you actually did any hands-on or you just studied for certification. Remember, you do not need to work on big enterprise projects to have technical challenges. As long as you try to do some hands-on, either in some open source project or your example pet projects, you will have technical challenges. But anyway, couple of answers from my personal experience is selecting appropriate service based on project requirements. So we talked about this. Let's say in your project, you have an option to choose either application load balancer or API gateway, or you need to choose SQL or NoSQL. So at least study these two. Another technical challenge in real-world project is achieve disaster recovery with low RPO and RTO. So there are different options to choose from depending on RTO and RPO for disaster recovery. Have one option ready in detail with example. So AWS actually provides one option where it does active and all that good stuff. So you can study this. So if you want to say this technical challenge and the interviewer wants to dive deep, you have one example that you can answer. Going back, another thing you might say is designing automated unit testing. Just going in the screen or calling the program manually, it's easy, but to implement it in CI/CD pipeline is difficult. So we already covered this in a previous question, so study that. And there is always challenge in cost optimizing. I was developer once. I did not care about cost when I was coding or provisioning EC2. But with this, give an actual example. Say that, my project spun up big EC2s. So we had cost challenges that we were spending a lot. So we used a couple of services such as Amazon CloudWatch Insights, AWS Compute Optimizer to suggest appropriate instance type. You also used AWS Spot instances for testing. And also you use AWS Cost Explorer reports to analyze your cost report for different workloads, different team, etc. You can also mention a couple of third-party tools such as KubeCost or Cloud Health. So especially if you are using Kubernetes, KubeCost, super good. By the way, not sponsored by any of these third-party tools, but I used KubeCost in my actual project and I really liked it. Next question, give me an example where you have used AWS well-architected framework. So I'll give the link to this map. So when you Google AWS well-architected framework, this doesn't come up. So let me open this website. This is an interactive map of AWS well-architected framework. You can see the 5 main pillars: operational excellence, security, reliability, performance efficiency, and cost optimization, and then the sub-pillars. But the neat thing is, let's say you want to give the answer that during well-architected framework review, you found out that your application is not secure, and then you took some steps. But interviewer is going to ask you what steps. So this map, if you click this, let's say you don't have incident response plan, and you can see if you hover your mouse, it kind of gives you a little description. But let's say this incident response, if you click this, once you click that, it is going to show you all the relevant materials, like how to prepare and respond to security incidents, automated incident response, DIY guide to runbooks, and a couple of materials to read. So whatever you decide, so choose based on what you like. If you like cost optimization pillar, you can always go to cost effective resources and then resource type, size, and number selection. We are talking a little bit about that. So you can click that and then study using this material, right? And this also gives the steps that you need to take to solve the problem. So use this map. I'll give the link in the description to study and prepare for well-architected framework questions. So the next question, this is super common in almost all cloud interview. You will get a question like, what is cloud computing, or what is AWS service, EKS or Lambda, S3, etc. So generally, a lot of candidates will just try to describe it. For example, cloud computing is storing your data and servers in data centers that you don't own. You can run your applications on cloud. Some cloud examples are AWS, Azure, GCP. But this is not a good answer. because it doesn't highlight the advantages of the cloud. What you need to do is just memorize the one-liner. So if I have given the link, what is cloud computing? So you can see this definition is crisp. It touches all the advantages. So you say this line and then you explain using your own words. Similarly, if you get asked what is service X, say the official definition and then you can explain in your own words. For example, these are the official definition for EKS, Lambda, S3, CloudFormation. I have them memorized. I meet with customers all the time and I get this question, hey Raj, what is this AWS CloudFormation? So I just give the official definition, then explain. And you will get this question in your real world projects as well, because sometimes you will talk with a senior manager, director, executive director, and they are not up to date with all the services because, and which is very understandable because they're dealing with very high level problems. So they might ask you, hey, what is this service? And you should be able to explain in a crisp and easy to understand way. All right, guys and girls, that's the video. If you found this video helpful, please click subscribe, click the like button, smash it if that's something you are into. Share this channel with your friends and family. Help this channel grow. Also, let me know in the comments if you like this video, what other questions you want me to go over, etc. All right, thanks for checking this video. I will talk to you guys and girls in the next video. Bye.